So we are now in chapter 5, and hoping everybody found their packets. If you didn't, my best advice is going to be make sure that you have everything organized. You know, you're labeling. This is example 1. This is the got it for number 1. All that kind of stuff, and then I think you'll be okay. So section 5.1 is where we're going today, called polynomial functions. And our objective today is going to be to classify polynomials and to graph polynomial functions and describe end behavior. Now, we probably won't be describing end behavior today. I don't know, we might get there. Yeah, we'll see how we do. But we're definitely going to learn about naming them. So when they say classify, that's what we're doing. We're trying to figure out, you know, what do you call these? And this little getting ready says, we're going to talk about how you can figure out what kind of polynomial you should use to represent your data. So the first column shows a sequence of numbers. -4, -6, 4, 50, 156, and 346. To find their first differences, remember difference means subtraction, we would do something like -4 minus a -6 or -6 minus a -4. Now, once you pick a way to do that, either top down or down up, you have to stick with it the whole time. So this book said, let's go ahead and take -6 and subtract a -4, and that'll give you -2. 4 minus a -6 is 10. 50 minus 4 is 46. 156 minus 50, and we'd write it in there. Now notice, you don't just do that once, because if we do it once, we don't see anything remarkable about those numbers. But if we do it twice, we might see that they're all the same. Sometimes we have to do it 3 times, and then we see that they're all the same. And what that does is it tells us which power we should use to write a polynomial that would have all of these points in it. That's a little bit farther than we're going to be talking about today, but we'll come back to that after break and do that subtraction. So now, on this page, you'll notice we've got a whole lot of blah, blah, blah. And that's because this is going to be fairly new to you, and that means we need guidelines. We need a box of, hey, this should be happening, and that's what this is doing. So a polynomial function has distinguishable behaviors. That means when we see a polynomial function, we should say, oh, look at that, it's going to have, and we'll know just by looking at what the power is and talking about what each one of those terms is going to do. You can use its algebraic forms to know something about the graph. So if we factor it, we definitely know we can find zeros from that. We've done that before. You can use the graph to know things about the algebraic form. So this is saying, if we give you a graph, you're going to be able to write these polynomials for us. And yeah, in the future, we'll be able to do that. Now, we have a little blank here we have to fill in, and that is a monomial. Now, I've already introduced you to this because I talked to you about those greatest common factors and how we're taking a monomial out. So it's one term. It's a real number, a variable, or a product of a real number, and one or more variables with whole number exponents. So just one term is called a monomial. Blank in one variable. This is huge. Degree of a monomial in one variable is the exponent of the variable. So if I write down 3x to the 4th, and they ask me to find the degree, all I do is look for the exponent. Hey, it's a 4. This is a degree 4 polynomial. In fact, it's a degree 4 monomial because it's only one term. Now, if we have one that has a string of them, then what do we say about the degree? Because this just said for a monomial, for one term all by itself. But we can actually for any polynomial, find the degree by finding the highest power of all of the x's. So this one would be a degree 3 polynomial. So we take a bunch of monomials and we put them together and we get a polynomial. Poly means many. So a polynomial. We don't usually tend to pronounce the E in polynomial. We just say polynomial. So a polynomial is taking one or more of those terms and putting those together. Now notice it does say that it's a sum of monomials. So terms are separated by addition. So that means, for this one up here, if we want to break it down into its terms, we need this all to be an addition. So the first term is 3x to the third. The second term is 2x squared. The third term is negative x. And then the last term is a 7. Why am I not seeing you guys? There we go. Now I'm seeing your icons. So this is a polynomial. Then, like I said, the degree of the polynomial is going to be the greatest degree. So this is another one where this is a huge thing for us. We want to check for that highest power of the x's. Now the reason we want to do that is because that tells us what the graph is going to look like. Believe it or not, if we just know what that highest power is, we're going to know what the graph is going to look like. It's all based on what this highest power is, and then whether or not this number in the front is positive or negative. A polynomial with the variable x defines a polynomial function of x. And the degree of the polynomial function is the same as the degree of the polynomial. So whether or not it says y equals 3x cubed plus 2x squared minus x plus 7, or it says f of x equals 3x cubed plus 2x squared minus x plus 7, makes no difference. It could be a polynomial, it could be a polynomial function. We want to find the highest power of the variable. Now, that's what we usually do anyway, because we like to write these in what's called, and that might be in the glare spot, descending order. So biggest power first, then the next biggest power, and so on. So 3, 2, 1, 0. We like to put that in descending order. That's called standard form. So that's usually going to be the first thing we do anyway, is get it into standard form. Now, that's what this box says. Standard form of a polynomial function. The standard form of a polynomial function arranges the terms by degree in descending order, descending numerical order. So you start with the highest power and you work your way down. A polynomial function in standard form, and I know this looks a little scary, but this is just algebra for saying we're going to put a number in front of an x with a power. Another number in front of the x with a power, and that's a polynomial. N is non-negative integer. We don't want to have any negatives in there for powers. We already know we're supposed to simplify those anyway when they happen. And a sub n to a sub 0, those are your coefficients. We're not going to work with imaginaries. Those are going to be real numbers. So this polynomial is 4x cubed plus 3x squared plus 5x minus 2. And we could break this down and say, this is a power of 3. That's called a cubic. So that's a cubic term. This one has a power of 2. Power of 2 is called a quadratic term. X to the first, that's called a linear term. And when you have a number that doesn't have an x, any variable back there, that's called a constant. In fact, we don't normally say constant term. We just say it's a constant. So, two ways that we can name polynomials. The one that we just looked at was giving them a name by their degree. What is that power that we saw? So right here, we've got our little chart, and it says if it's a degree 0 polynomial, well, that would mean it doesn't have an x in it. That was the constant. So those are called constants. And 5, that's a good one. It's just a number. Any number could go there. But there's another way to name that 5 as well. And that's because there's only one term here. And if it only has one term, it's called a monomial. So, like this very colorful statement up here says, a polynomial can be named, classified, by degree, or it can be given a name by how many terms it has. This one would be an x to the first. We see it right here, x to the first plus 4. Well, those graph as lines, so those are called linear by degree. So when you have a degree 1 polynomial, it is linear. Then we look at x plus 4 and we see, oh, there's two terms because there's a little plus, so there's two of them. And if it has two terms, this was a monomial, this is called a binomial. Now, if you're thinking, hey, I've heard these names before. Yeah, I've been using this vocabulary as we've been talking about these. 4x squared. Okay, x squared. Those are parabolas. They have a fancy name. They're called quadratics. So a degree 2 polynomial is a quadratic. But looking at it to say, hey, this is how many terms it has, it's only one term. So we're back to a monomial. The next one, this is the highest power, 3, 2, 1. So that's going to be, the name on degree is going to be based on a 3, and that's called a cubic. Again, some of this language you've heard before. But this one has 3 terms. So let's think here. Was monomial, binomial, 3, well, like a tricycle has 3 wheels. It is a trinomial. The next one has a degree 4 polynomial. Notice the highest power of the x is a 4. Those are called quartics. Quartics. Do you see how that's a lot like the word quarter? Quarter of a dollar is a quarter. So quartic. But it only has 2 terms, so now we're back to a binomial. So 2 different names based on what they ask you to classify it by. And then this one. Well, the highest power of the variable is a 5. So what do they do with that? Well, I don't know if you follow this stuff, but every once in a while somebody has lots and lots of babies at one time. And they called them quintuplets, which means they had 5 of them. So quintic. Quintic. But it does have 4 terms. Now, we have fancy names for all of the degrees. If you went online, you'd find out they've got, in fact, there's a cool one that starts with hen, and since I like chickens, I like that name. But we're probably only going to go to degree 5 polynomials at the most, so we do need to memorize linear, constant, linear, quadratic, cubic, quartic, and quintic. But after you get so many terms, because polynomials can have an infinite amount of terms, we're just going to say it's a polynomial with 4 terms. So we have the special names for 1 term, monomial, special name for 2 terms, binomial, special name for 3 terms, trinomial, but after that we're just going to say it's a polynomial with 4 terms, it's a polynomial with 5 terms, and we'll use that. So this chart, hopefully, you will memorize by accident, and it won't take very long to memorize constant, linear, quadratic, cubic, quartic, and quintic, and you'll have those down. And most people don't have any trouble with the number of terms because they just think, okay, well, if you think about this in terms of bicycles, you know, bicycles have 2 wheels, a monomial is a unicycle, and then a trinomial has 3 wheels on it, and then you're fine, and you've got them all. Because literally, to start this chapter, all we're going to do is tell them, what should this be named? So, problem 1 says we're going to classify these polynomials, write each polynomial in standard form. Yeah, that's step 1, always. What is the classification of each polynomial by degree? So tell the name according to the degrees, and then by the number of terms. So first things first, standard form. I notice that the squared is the biggest power of the x. That needs to go in front. then the 3x to the first, and then the constant that doesn't have any x with it. So there it is in standard form. Now, I have to tell them what the name of this would be based on the degree. So I look at the powers of x, no x, x to the first, x squared. So this is a degree 2 polynomial. And degree 2 polynomials are called quadratics. So it's a quadratic. Then, by the number of terms, well, it has 3. They're separated by addition here, 3 terms. And 3 terms are called trinomials. Alrighty. I would like you to put B in standard form, please. And then give it a name according to degree and the number of terms. And then I'm going to ask for your help. Everybody ready? Can somebody tell me what they wrote down for the standard form of this polynomial? Please unmute. Don't be shy.
Positive x to the fourth plus 4x squared plus 4x minus 12.
Thank you. Fabulous. There it is. I don't know if you noticed, but it didn't have a cubic term in there. That happens sometimes. You know, sometimes we don't get them all in perfect order, 4, 3, 2, 1, 0. But there it is in standard form. So now, I would like someone to unmute and tell me the name by the degree.
Degree 4 quartic.
It is. Perfect. And then I need somebody else, and I'm not going to write out number of terms anymore. I'm going to put the little hashtag for number terms. Somebody please unmute and give me the name.
4, so a polynomial of 4 terms.
Thank you. Polynomial of, I almost forgot the A. Polynomial of 4 terms. Yeah, we don't get a fancy name. Remember, 1 is monomial, 2 is binomial, 3 is trinomial. After that, we just say, hey, it's a polynomial of 4 terms. Alrighty, some got it's. Write each polynomial in standard form, and then again, what's its name? Classify it by degree and by its number of terms. Go ahead and do that for 1A and 1B, and then I will ask you to help me. I went ahead and wrote down the standard form for that polynomial, but I would really like somebody to unmute and help me out with the name according to the degree. That would be great.
Degree 4 cortex.
Good. And according to the number of terms, please.
Trinomial.
Good. And then for B, oh, forgot the little negative there. I was just going to say, make sure you always take along the sign that's right in front of each term. So this 3 is like a plus 3, says there wasn't anything there. So now I need somebody to help me by giving me the name according to the degree. Please. Yes, a quintic. And then somebody please unmute and give me the name by the number of terms, please.
Trinomial 3 terms.
Okay, I think I heard you wrong. Polynomial of from this end, it sounded like 2 terms. I don't think there's 2 terms here. Polynomial of 4 terms. But yeah, it was cutting out too. The sound was cutting in and out. So
Did
that,
the 10 and the 3 add together?
oh, for goodness sake, look at that. Here I was going through all of this and I never combined like terms. Thank you. So yeah, that's going to be a trinomial. Yeah, I didn't put them together. Again, I wanted to make sure I was talking about, make sure you put the negatives in front of the terms as you go through there, and I got myself all discombobulated. All right, next up. So part of your homework and part of the objective today was to classify, give them names. And that was it. I mean, that's what you're going to do for part of your homework today. This says if you're given a set of polynomial function outputs and the inputs differ by a constant, you can determine the last degree of the polynomial function that would generate the data. Now, this is just like the little icon that we had when we started out that had the avatar on it, the getting ready piece there. But we're going to go through how this all works. If the first differences are constant, then the function is linear. So we're going to do a bunch of subtraction. And if when we do that subtraction, we see exactly the same number right away, then that means it's a first degree polynomial, which is linear. If the first ones don't match, so the second ones do, but not the first ones, then it's a quadratic. We're trying to figure out what type of polynomial could we write that would work for these points, and so on. So we'll do subtraction. If it gives us the exact same number every time and it only happened after the first subtractions, it'll be called linear. If we have to do it again, but then they're all the same, then we'll call it a quadratic. If we have to do it again and they come up to the same thing, then it'll be a cubic, and so on and so forth. So that's what we're going to do here. What is the degree of the polynomial function that generates the data shown below? And then, like it says, use differences to determine the degree. Difference is subtraction. Now, Here's something really important that they mentioned, but it was really fast, and that is these x values have to be going up by the same amount every time. So we're going by ones here, and they're all going by ones. That's called an interval. The interval for each one of these is a 1. That's great. And then, like I said, you have to decide, how do you want to do your subtraction? Do you want to do it from the top down or from the bottom up? But once you pick that, you can't change. You have to go the same way for every single one. So here's what we're going to do. -1 minus a -7. Well, -1 minus a -7 would be -1 plus 7, which is 6. -7 minus a -3. That'll be -7 plus 3, which is -4. -3 minus 5. -8. 5 minus 11. -6. 11 minus 9. 2. 9 minus a -7. 16. Now, it's pretty obvious those did not come out to be the same. So that means we can't use a linear polynomial to do this. So this was the first difference, and it didn't work. So we have to keep going. So even though these didn't come out to be the same, it is important that we did our subtraction right. Because if we don't do our subtraction right here, then we're not going to get the right one to come out as constants. So we'll keep going. Do that subtraction again. 6 minus a -4. There, that's better. This one got kind of carried away. I'm going to line up a little bit better. 6 minus a -4 would be 6 plus 4, which is 10. -4 minus a -8 will be -4 plus 8, which is 4. -8 minus a -6 will be -8 plus 6, -2. -6 minus 2 is -8. 2 minus 16 is -14. That is not the same number. Look at this list vertically. It's not the same. 10, 4, -2, -8, -14. That was the second difference. So this is not a quadratic because those numbers did not come out to be the same. Let's try again. 10 minus 4, 6. 4 minus a -2. Well, that's going to be 4 plus 2. Ooh, that's good news. -2 minus a -8 will be -2 plus 8. Oh, this is looking better. -8 minus 14 is -8 plus 14. Aha! We found it. This, oh, come on, blue marker. This is the one that worked. So that means we would want to use a degree 3 polynomial. Anybody remember the name, the classification that we have for third degree polynomials? Yeah, so we would use a cubic to best show what this data is doing. We would use a cubic for that. So really, this is just subtraction. But you want to go slow because you don't want to mess up in the early steps. And then, you won't be able to find a constant. So the got it 4a says, what is the degree of the polynomial function that generates the data shown? We've got another one down here. And then 4b, what is an example of a polynomial function whose fifth differences are constant but whose fourth differences are not constant? Well, we might not actually do that one, but let's focus on got it 4a. Again, I check 1, 1, 1, going up by ones. All right, so all I have to do is subtract. So I need 23 minus a negative 16. That's going to be 23 plus 16. That's 39. Negative 16 minus a negative 15 would be negative 16 plus 15. Well, we already know it's not a first difference polynomial here. Negative 15 minus a negative 10 will be negative 15 plus 10. That's negative 5. Negative 10 minus 13 will be negative 10 plus 13, which is 3. Negative 12 minus negative 12. Negative 13 minus negative 12 will be negative 13 plus 12, negative 1. And negative 12 minus 29, negative 41. Now, pretty early on, we knew the first difference was not working. I mean, right away, we did 39, then negative 1, so we know first difference isn't going to go. But let's try second difference. 39 minus a negative 1 will be 39 plus 1, which is 40. Negative 1 minus a negative 5 will be negative 1 plus 5, which is 4. Negative 5 minus 3 is negative 8. 3 minus a negative 1 will be 3 plus 1, which is 4. And then negative 1 minus a negative 41 will be negative 1 plus 41, which is 40. That's kind of interesting. Look at that. 44, negative 8, 4, 40, but they're not the same. So it's not a second degree polynomial either. But the fact that we're starting to see a pattern is good news. So 40 minus 4, 36. 4 minus a negative 8 is 4 plus 8, which is 12. Negative 8 minus 4, negative 12. 4 minus 40, negative 36. It's not a third difference either. They're not the same number yet. Let's try again. 36 minus 12 is 24. 12 minus a negative 12 is 12 plus 12. Oh, 24. Negative 12 minus a negative 36 is going to be negative 12 plus 36. We found it. So this data, we'd want to use a degree 4 polynomial. Can somebody unmute if you remember what the name of a degree 4 polynomial is, please?
Quartic.
Thank you. It is a quartic. So big objective piece that we did today was we classified. And that was just according to that chart. We're learning the names. And then the second piece of this is, what kind of polynomial would you use if you wanted all of this data to show up when you graph it? And that's what this difference piece is doing. Now, I didn't want to get too far into chapter 5 because we're going to be gone now for a week and a half or so. So let's hold off on 4B. I don't want anybody getting, confused by the fact that we throw in a hiccup on all of this. And let's just stop here where we're just doing some basics of naming and we're doing some subtraction to see what degree of polynomial we should have. And we'll leave the rest of this wonderful stuff for after we come back from holiday break. I'm going to take a quick peek at this assignment and make sure that everything that's on here is something that we talked about today. And it is.